Okay, so good morning, everybody. I'm Sean Conaway.
I'm Josh Patel.
I'm David Ritchie.
And I'm Austin Hinkey.
And we are Group 12 presenting our design for England cars. So a little background information. The King just held his big ceremony for the Kingdom of Car build. Unfortunately, the dastardly villain Pierre the Nasty has broken into the inauguration and stole the King's crown. So it's up to you, your police squad, to take the crown back using the King's specialized car. Now, a little background mechanisms that we're using. So to propel the car, we have your basic like pull-back car. So you have a set of gears that winds up a little constant force spring. When you let that go, then it propels the car forward. And for the launcher to capture Pierre, we have a bumper up here that when it gets pushed in, it enacts a series of levers that releases this launcher projectile through a spring. And for a moving target, Pierre, we have a simple slider crank mechanism that's just powered by a little AA battery. Hand it off to Josh.
Okay, to give a little background on our target, we're looking at ages 4+ just because we do have that projectile, and we do have some smaller pieces that may be swallowed, so we're looking at a little higher age range. Also, we're looking at kids that like hands-on interactive toys because with this toy, there's a lot of inputs you put in, there's a lot of things you can control in terms of what angle you want to launch the projectile at, what speed you pull back the car at. There's a couple of different things in terms of the input, so we're looking at that as maybe a marketing point and something that we want to look at for our target market. Also looking at competitive and goal-driven kids because there's a very yes or no, whether you knock down the target or whether you don't knock down the target, you have to try again. So that's something we want to look at in our market. And lastly, a focus on math and science because there's a lot of engineering, there's a lot of mechanisms and design that goes into this. So we believe that this will stand out to kids that like math and science. So then looking at what makes our car unique, so it's a little bit of a twist on the conventional wind-up car by having that projectile on top and having that cam that launches the launcher. In order to hit the target, there's 3 different inputs you can mess with. So number 1 is you can push the car from left to right because we have this target going left to right, so you can aim it like that. You can pull back the car certain distances, so if you pull it back more, you're going to get more force. It's going to have a higher velocity, and the target will go further. And then lastly, you can also adjust the angle. So if you look at the top right, that's one of the pieces that will control the angle that the projectile launches at. And then we also have a moving target. So this is something that we did a little bit extra. Instead of having a static target, the moving target kind of adds a little bit of playability, adds something to look at. It makes it more interactive and more interesting to play with. So looking at our play value, like I talked about earlier, it's very hands-on, so it develops coordination because you have to aim and try to hit the target when it's moving. Also, it's a combination of mechanical and electrical devices. So we have the DC motor, which is our primary electrical component. We also have the gear system and the cam launcher, which is pretty heavily mechanical, and it combines these two into one toy. So looking at our variations, so there's a couple different ways you can play this toy. So you can do speed times or trial times to see how quickly you can knock down the target. You can also swap out the target. So right now we have it set up based off our Pierre the Nasty story, but you can also switch that out pretty easily for different gameplays. And then lastly, looking at the car speed, like I talked about earlier, you can pull it back different distances, which will correspond to different launches, and that can add a different variation on how you play the game.
Okay, just going a little bit more detail about our first mechanism that Sean and Josh talked about earlier was the wind-up gear motor. So just a quick overview of how it works. You can see on the left side kind of a cutaway view of the motor. There's 4 gears on this side that wind up the spring, and it works for this bottom gear is a drive gear, and it's attached to the axle of the wheels. And when that winds up, it transfers the motion to a transfer gear, and then to a floor gear, which is the smaller one up top. And that final gear is a spring gear connected to the constant core spring that winds up. And then play the video. From the video, it's kind of hard to tell right now because it's moving really slowly, but it's moving one way, and then about halfway through, when you would release your hand off the car when you pull it back, you see these 2 gears shift positions. That happens from like these two slots in here. So it's when it's going one way, gears kind of lock in place, and it allows the spring to be wound up. Lower in hand lifts off, the spring engages and pushes the gears back the other way. So that's how it can kind of work using two different motions on one gear system. So this next picture is just the flip side of that. So that spring on the big gear you can see is a constant force spring. Drag the gears. Now pass it to Austin to talk about the other mechanisms.
All right, so we got pretty creative with our launcher mechanism. First off, we wanted to make it so that it would launch when it hits something. So we have kind of a stopper made. What it does is it uses the bumper here. When the bumper depresses, it actually is connected to a cam right here, which when that gets pushed back, it pushes up the follower, which then releases the lever, which is spring-loaded, and it launches the projectile. I'll keep it here just a second, actually. The reason we have it, we designed the launcher like this, is so that it could be varied at different angles, so that you can shoot it at a 15 degree, 30, 45, and 60, which is kind of extreme, we figured out, but hey, you know, kids want to have fun. So anyway, what we did is we designed it around this point right here. So this is the center, so that when this moves, this essentially stays in place, so that we didn't have to worry about the variability of the length of the follower, because we found that was very important. We also had to design this little locking mechanism to be similar to the angle at which the cam was. That way it would release it when it was hit. So now you can move on. We'll just show a little demo of how it works. So you got your car rolling, and it's going, and as it depresses, it stops, which pushes up the lever and releases the projectile. And then we've got one more full animation of, then the slider crank mechanism. So we used a DC motor powered by a AA battery, which is just a simple 4-bar mechanism with a guide. So it just goes back and forth with Pierre Lanasty. And he also is on a, I can't think of the word right now. Slot, sorry. So when he gets hit, he'll go down, and that's kind of like the goal that we're going towards. We also have a little cityscape here. So here's our full toy animation. Not sure why it's not playing.
That's it.
What?
Okay, you just continue your statement.
Well, we can do it. We can try a live demo. We'll see what happens here. So we also found one of the issues was the constant force spring was not quite as strong as we would like it. Since this car it's got quite a bit of mass to it, it doesn't actually propel it forward enough, but it still works. You can kind of hear it clicking, and it'll go forward. It just doesn't have enough to propel the car, so I'm just going to give it a little push. Got it.
We'll open it up to questions now.
The angle? Okay. So what we have is we have a pin right here that you can take out, and you can just turn it like this, and it slides. And we've got different, let's take this out, different holes, as you can see here. So it's adjustable like that. And as you can see, like I talked about in the design, as you turn this, it keeps it in the same position so that the follower stays in the same position. So we can try and, yeah, this is a 45. Let's see if we can. This might go really far, I'm not sure. Yeah, so as you can see, we're also going to work with the variability of the distance of the track so that you can launch it from different angles and whatnot,
If we had
different distances.
If we had a little more time, then we would have made this kind of telescoping so that it set where you wanted it to launch. So that would have involved a little more the educational side of things, so that you know, like, how far away the launching distance, how the angle affects how well it hits the target.
In the folder. Yeah, we worked hard on this video, so we got to show you our little production here.
This is our commercial that we'll output to the media.
So yeah, so that's how it works.
Anyone has any other questions? We'll take